I've received a few questions in the comments section about my rear tire carrier and my rear bumper. So this is a custom fabricated bumper that I designed and built myself in my garage. And so I'm actually going to disassemble part of it now because I'm going to be attaching a high lift jack mount to the rear bumper and tire carrier. So I wanted to just go ahead and show you guys how I designed it and kind of explain why I did what I did. Now, just to be clear, this is not any type of recommendation or suggestion on how you build yours. You need to be confident in your fabrication skills and design it the way that you think it makes sense. So first things first, I do got a heavy duty cable bike lock on here. So I'm going to go ahead and take the padlock off and I'll show you how it attaches. Off-roading tires are very expensive, so I don't want anybody walking off with one of my new tires. So you can see from the side profile here, I've got a 1/4 inch plate and it's just got 3 lug studs pressed through it. I've actually got a couple washers on here, and that was just because this plate is not perfectly, say, parallel to the back edge of the vehicle, and so my tire just kind of looked crooked. So that's just a spacer. And it's just got a square tube. It has another little square tube welded up down here. That's where I cable locked the tire to it. And it's just got some gusseting under here to reinforce this 90-degree angle. I do have some gusseting on the top and bottom of this tube, and I tried to do the gusseting in a way that makes sense as far as the different load cases that a tire carrier is going to be used on. So just thinking about when you're driving a vehicle, the most common load case that you might think about is going to be a vertical impulse straight up from the tires. Now you're lucky because your tires and your suspension is going to isolate that vibration and that impulse from the frame, which this bumper is mounted to the frame. The other common load case is going to be a forward and back type of vibration like this, from speeding up and from braking hard and just from different undulations in the road. So that's why I used vertical gussets, trying to make sure that if the tire is rocking like this and it's being pushed back and forth, that it's reinforced on the top and bottom. I didn't really think that there would be a lot of lateral deflection, so I didn't really do any gusseting on the side. So the square tubing that I used for the tire carrier is 2-inch square tubing with an 1/8-inch wall thickness. Now a lot of people would say that that's too thin. A lot of people use 3/16 or even 1/4, but I think that's a little bit overkill, specifically for this type of design. Going back to when I mentioned different load cases earlier, the common tire carrier actually has a hinge all the way out to the side, and it has a crossbar, so you actually have 2 different lever arms that the tire is acting on. So a lot of the weight of the tire is going to be up here. So when you have a hinge over here, you have basically a big cantilever action where the weight and the vibration of that tire is going to be trying to bend the hinge. Since I have my hinges and my pins directly vertical underneath this tube, this whole tube is in compression from the overall weight of the tire and from any vertical impulses. So that's going to be the strongest orientation for a tube. Likewise, any rattling back and forth is just going to basically act as a lever. So you do get a lot of forces on the locking pin down here because this is a big lever arm. So it's just like a breaker bar. It's applying a lot of torque. I did do some basic calculations just to make sure that my stresses that I thought that I would be seeing there were going to be within the material limits, and it seemed like even for an 1/8-inch tube it would be. So I have a 5/8-inch hitch pin that just has a handle. Just release it and it pivots down. Now if you look where that pin goes through, I have a large hole drilled through it, and then I actually used a little sleeve bushing that I just welded in place, and the purpose of that was just so that the inner bore would actually match the hitch pin, but I wanted to drill a bigger hole because that's going to distribute the stress on this pin to a larger surface area and the wall thickness. So when you look at, say, the wall thickness there and then the diameter of the hole, and you see how much surface area that stress and that force is going to be applied over, that's going to be much less likely to damage or yield your material. So you can see how I actually mounted the pivot point. I've got some vertical plates here. It's actually doubled up on the top, and that's not for any real reason other than I misdrilled the hole. So I had to align the holes better. Basically my tire was leaning too far off the back of the vehicle and I wanted it to sit a little further back. So that's why I've got it doubled up here. And then on the back of that angled piece, it's tied into the bumper right here with welds, and it's tied into the side pieces. So these side pieces are very rigid left to right. So this is a 1/2 inch grade 8 bolt, and it's got a regular washer and a locking washer on it. On the bolt head, same type of washer, and I'm going to take this out slowly. And these are the oil lubricated, oil impregnated bronze washers. These are basically thrust bearings. And this just allows it to give it a nice bearing surface while it's rotating, and also put some lateral pressure on it so that it doesn't flex side to side. Now you can see the bottom of this tube. I had to notch it out to allow it to rotate through, and so I just took an 1/8 inch steel strap and bent it over just to give it some rigidity. And you can see the steel bushings that I've got welded inside this tube. And I ground it nice and smooth so it has a nice flat surface for those thrust bearings to ride on. So looking at the side pieces here, right, you got the 2-inch square tube across. I've got a 1/2 inch rectangular tube here, and then I've got a 3/4 inch recovery and shackle clevis. And then I've got 1/4 inch plate right here. So if you add all that up, this whole width is 2 inches. So I tried to make it so visually you got a 2-inch tube here, 2 inches here, 2 inches on the bottom tube, and then 2 inches around the trailer hitch. So you might be able to see up underneath this tube, this is where the 1/4 inch plate comes in. It sits on the outside of the frame rails on both sides. There's 3 bolts with the corresponding nuts. Now I've actually got a CAD model that I had designed up when I was trying to come up with the bumper design. So I'm just going to throw that on the screen because I think that'll help show you some of the detail. One other thing that I wanted to point out is that this recovery shackle, it is welded around the tubes here, and it actually is sandwiched at this 1/4 inch plate gusset, and you see a bolt head right there. Now bolts are a good thing to secure your recovery points because bolts typically have a very predictable shear strength before they break and give way, whereas welds have a very predictable material strength, assuming that your welds are actually good. So you typically don't want to rely on welds unless they are done by someone that is very skilled at them for any type of recovery gear. So since my clevises were going to be in a perfect spot right at the edges of the gussets, I went ahead and put a 1/2 inch bolt through there just for some added reinforcement. So I almost forgot to mention, but this is kind of fun too. There's a bunch of leaves back here. Unfortunately, that's a nice collection spot, but I did make sure that I left 2 drain holes, so if water gets in, it's not going to fill up in this pocket, and it'll allow it to drain out the corners. So that was just another little detail that I thought about adding with this tire carrier. For the license plate, I actually drilled and tapped holes. My license plate light is a little bit cracked, so it's not staying there, but I do got screws that are have holes that are tapped into the steel, and I just got a nice positive 12 volt and ground wire with a weatherproof 2-wire trailer connection wiring. You can get that at AutoZone in the trailer wiring section. It's the same type of thing that I use on my light bar as well.